Okay, so no strangers here, Alexey and Dwight. We have invited them to come tell us the latest on the interactivity extension for glTF. Interactivity has been a hot topic for this working group over the last year or so, and there's a few different approaches that could be taken at different levels of complexity versus flexibility. And the glTF folks are using a behavior graph, and we especially wanted to hear from Alexey and Dwight today for folks in the USD community to see how glTF is approaching this to hopefully over the long term, maybe facilitate some interoperability. So Dwight and Alexey, thank you for coming. Always a pleasure to have you. Over to you for your presentation, then hopefully a lot of great Q&A.
Yeah, great. Thank you. All right, so some of these slides are what was shown at SIGGRAPH, but many of them are ones that I added that hopefully address some of the questions that I think you all have. And if they address the wrong questions, then I've got all the rest of the slides from SIGGRAPH, and I can always jump over to where your questions truly are. This was just the roadmap slide that we showed at SIGGRAPH. Interactivity, we are hoping to be just about wrapped up with the base spec of interactivity now. We were making a couple last minute adjustments on sort of how does its extensibility work, specifically around optional extensions, but it's pretty final at this point, I think. It is further extensible, but if people look at the spec as it is today, it's pretty much in final shape. So the big question, I think, is what are we trying to achieve? Because interactivity can mean many different things. And so one of the simplest problems that existed in glTF was that you can create a static scene. You can also put animations in it. You can put more than one animation in it. You could not provide any information that would tell anyone at what point should these different animations run. And so if you intended, for example, to have a toaster or a car or something, and clicking on the steering wheel should turn the steering wheel and the wheels, and clicking on the headlights should make them flash, and clicking on the trunk should make the trunk open, right? There's nothing to know that those clicks should go with those animations. If it was a toaster and you're supposed to be able to click on the button to press down the toast, right? There's no indication that that's supposed to be connected to that animation. So what you had to do previously was you had to hard code your own viewer application. You could use Babylon or 3 or whatever in your website, and you could put some JavaScript in there that reacted to things. But that was not portable. Your content now had to run on your site, and it couldn't run on any other site. That was the basic thing we were trying to solve. And so the simplest way to solve that would just be to say, okay, well, here are some objects, and when you tap them, these are the animations that play, and maybe here are the sounds that play. So a tap to play would be simple, but there's a big question of whether that does enough. Are there things that other people want to solve that's not good enough for? There was a trigger and action approach. That's actually what my team had taken. Apple had also taken. Apple, I believe, proposed a schema for USDZ specifically for trigger and action, which basically is a superset of tap to play. In addition to tap to play, you could also say tap to do something else like move, rotate, etc. And you could also have triggers that are not taps, potentially that you got close to something, for example, instead of you tapped it, or two objects got close to each other. This is what we originally went to Khronos with as a proposal, because we thought, hey, we've already got this stuff that's pretty similar to what Apple's doing. Maybe we can get this all aligned. We ended up bumping up one level to node graphs. Pretty much all trigger and actions are node graphs, but not all node graphs are trigger and action. And we'll talk later in the slides about what benefits that gave us. But basically, we found that there were a lot of people who said, yeah, trigger and action is not going to meet all of our use cases. Let's go one level beyond that. And you could go all the way to, let's make an intermediate language. Let's do everything in WebAssembly. Let's just have a standard JavaScript API and bring your JavaScript with your content. And there are some reasons why we didn't go that far. So we took sort of the spot between those two extremes. So the typical use case that made us feel like the trigger in action was not quite good enough and made us go with the models that the other members of Khronos had preferred was that if you wanted to do something like a product configurator where maybe you can press something to change this is, I think, a coffee machine, you may want to be able to choose which of multiple similar coffee machines are you using, and then you might want to configure the color or something of that sort. These are things that are very hard to do with trigger and action because you need to change the state of the scene. in response to things. And then you need to be able to react to those differences of state. Sometimes you can do it in trigger and action, but your trigger and action systems end up getting extremely complicated. Sometimes you have combinatorial explosions where you need a number of triggers and actions that are an exponential number of the states that you have. Some other use cases we wanted to cover were explainers and infotainment, things of that sort. You might want to be able to see whether you might want to be able to sort of get information about things in a museum before going to the museum. You might want to be able to get information from an aquarium, that sort of thing. Many of these are relatively simple and could be done in trigger and action, but some require a little more. Clickable objects, like we talked about, you might want to have a toaster, and before you buy the toaster, you click on various parts and either see an animation, hear a sound, or maybe get additional information about that part. Mini games, kind of a reasonable thing to try to do sometimes. We've seen some built with trigger and action. Usually it's easier to do those with node graphs. And then you could potentially have a larger ecosystem in which you want to be able to put interactive objects into it. So you've designed this toaster that when you click on it, it heats up or something. Maybe you want that to go into some sort of metaverse thing, and being able to have how does the object interact come with the object when you import it. It makes it easier to put these things together. Now, at the same time, we also wanted some limitations. People on the Chronos side were not comfortable with the idea that you just put native code into these things, or you put your JavaScript into these things, because as an implementer or as a person who is creating that environment in which the content loads, you want some more constraints around the content to be confident that you can load it. And so one of the most substantial ones that we did, which makes it far below the level of writing custom JavaScript, is we do not allow dynamic allocation. There's no ability to instantiate new objects. There are no array variables. There's no dynamic strings. There's nothing at all that makes the size that you're going to be operating at runtime bigger than what you can calculate it should be when you load the file. Only exception to that is event queues, but we do not require you to maintain a full event queue. You can place whatever limits you want as an implementer. So this is important for people who want to understand what is the resources going to be for the content that they're loading. We also, of course, don't allow network access. We don't allow file system access, and we don't support multi-user capabilities. If any of those want to be added, they would be added by the environment that includes the content. It's not fundamental to the content itself, and that way the content can be generally implemented in a secure way, where you don't have to worry that the content's going to be malicious. And that creates some non-use cases. We specifically are not trying to make this a system to author your next AAA game. AAA games will absolutely need dynamic allocation of memory. There's no way they're going to be producing this capability. Similarly, you could not create the metaverse, something where you're loading in content, because you can't load content. But you could create objects that could go into such an environment. And then similarly, this is not a system for general purpose computing. You might be able to figure out how to calculate pi to several million digits using a node graph, but please don't. That's not what we designed it for. All right. So this is a link to the spec. Anyone can read it. It's in pretty good shape. There may be a couple changes left on how we deal with extensibility of future extensions, but it's in pretty good shape. The approach that we're taking is a node graph approach. Node graphs are used in systems like Unity, Visual Scripting, Unreal's Blueprints, and NVIDIA's Omniverse. And we give you a set of sort of get and set nodes that you can use to change any variable within the 3D state of your object, including not just immediately set them, but animate them to a new value. And then we also give you branching flow and logic. The branching flow and logic and the math capabilities are the main things that give it a level up beyond trigger and action. We think that this is accessible and powerful. We have designed this in a sensible way. While this concept comes from visual editing, there's no need that you have to have used a visual editor to produce these node graphs. And you wouldn't have to have used a node graph based visual editor. You could certainly use an authoring tool that is trigger and action based, and then export to a node graph. That would be fine. So some of the questions I assume you're going to want to ask, is it compatible with those other things I just mentioned, Unreal Blueprint, Unity Visual Scripting, and on-reverse action graphs? And the answer is no, not yet, because each of those has a different set of nodes, and therefore they are not compatible with each other. There's no way for us to make one thing that is compatible with all of them, but it is possible for anyone who cares to create importers and exporters that would make much of the content compatible. There are certainly capabilities, since we just said we don't support dynamic allocation of memory, there are certainly capabilities that you could put in Unreal Blueprints, visual scripting, or in omniverse action graphs that could never export to our capabilities. But as long as the author doesn't use those, then it should be theoretically possible for importers and exporters to convert most content that way. And of course, going from the interactivity graph to Unreal, Unity, etc., should be more doable because all of ours should be a subset of what those support. Is it extensible? Yes, absolutely. So glTF already has an extension model and you can add new extensions with it. We have made it so that any new extension can define new capabilities that interactivity can work with. That works for both required extensions and optional extensions. Optional extensions are ones where your content should fall back gracefully if that extension is not present in the implementation that you're using. These extensions can be ratified Kronos extensions, or they can be vendor extensions where people are doing something unique to their own environment. And even if interactivity itself is not available, your content can fall back to being static. So there's no harm in loading interactive content into a system that doesn't have interactivity support. So does this work with USD? No, as far as I understand, the only thing that we've got in USD for interactivity right now is the trigger and action proposal. And while it's probably possible to export every trigger and action into a node graph, no one has written that exporter yet. And the vice versa is not possible. You can't take the average node graph and turn it into a trigger and action because node graphs are more expressive. Now, could we put this same capability that we just put, the node graphs, could we put that into USD? With a little adaptation, I think that should be possible. Right now, the way that we refer to each property, like how do we reference which property we're talking about and which node are we talking about that the property is on, those would need to be translated because things are done differently in USD than in glTF. But most of the system, I think, could go exactly the same way, right? Most of the nodes and everything could be done as is. And that would mean that that the translation back and forth between an interactivity object in glTF and one in USD could be quite easy. All right, so if you wanted to try it out, this link here is a link to the current sample implementation that has been brought up to speed with the spec. That's a great place to sort of try it out. It lets you both author and try your results. And I can't speak on behalf of other implementers, but I do think you'll see this in Babylon relatively soon, based on the progress updates they've been giving along the way. And we have other people also working on other implementations. Again, I can't speak on their behalf as to when each will release, but I do expect that as we are finalizing the spec in the next probably week or two, I'm expecting that the rest will get their implementations done soon. Those are all the slides that I figured I would present today, and then I was going to hand it over to Alexey. I have a bunch of slides on the details that were shared at SIGGRAPH, and I figure I will refer to those at Q&A if people have particular details they want to know more about.
Very nice. Thanks, Dwight. So we'll roll right to Alexey, then we'll do a Q&A afterwards. Does that make sense?
That sounds good.
Alexey, we can see it. And then if I could chime in for 1 second, there is a question in the chat if we have the URL for these slides. Do we have that yet, or we'll just send it afterwards?
Yes, it's in the portal. I can send it right now.
Okay.
Thanks, Sarah.
And I can also take the two important URLs from my deck, the specification link and the where do you get to try it out, and I'll put those in the chat as well so that people can jump directly to those if they want.
So that will be, I assume, really quick one. I want to introduce the way how we collaborate with the other one. So basically during the interactivity, with other extensions. So yeah, during the interactivity discussions, we kind of came up, we should consider the way how we will interact with any future kind of extensions. And we came up, as Matter, we came up with the idea with a new extension we call audio graph, actually, that's supposed to represent complex audio scenarios. And I thought actually that's a great idea to see how we can kind of paving this way for the future extensions, how we can collaborate with the interactivity. And basically it's like a really quick overview what the current thinking is and present that's the kind of future ideas. Really quick about what is KHR audiograph. So yeah, that's a draft state. As today, there is no spec, but proposals, which is 60% of the spec actually, so it's not too far away. Idea is we want to provide a way to create the node-based audiograph that basically connects the nodes, audio nodes to be specific, to create some complexity for DSP processing. And because of the nature of this extension, it's kind of really feature-rich, but the point is, it's not like audio playback. So you have to create some sort of the scene understanding and some sort of complexity on top of this. So we provide a lot of flexibility how you can express the audio pipeline for the assets. And the main concern actually that we get out of this, so the spec itself as audio graph, this probably makes not much sense to introduce because the actual real use cases, as the example here, they way more complex. So there's no easy way they can get audio DSP processing and start to apply to any kind of content because it requires some altering pipeline and then requires kind of some real use world scenarios. And this is super typical the way how the designers, audio designers approach integrating the assets. And like, for example, instead of playing one single asset, they have the set of the different assets they want to choose randomly and then play based on something, right, happens in the application. This is super typical scenario here. And the audiograph spec allows to create all the, again, complexity for DSP, run all the processing for it. But there is no such thing as random. It's probably no point to put it as part of audiograph because it's a sort of runtime behavior. Meantime, it should be expressed somehow. And we kind of came up with the idea why it cannot be just interactivity. So this current proposal, it looks like easy as this. You're just taking two nodes from the interactivity graph, connect to the audio graph source, animation pointer, using animation pointer, and that's it. So pretty much that's easy as this. And if you look in the actual real world scenarios that we get, at least as an examples from our audio designers, they kind of, all of them, they fit pretty well. So I have some sort of shuffle, random, or like sequence scene, etc., etc. And what I want to actually demonstrate that we, for the future extension, similar by complexity, we introduce like this new way that you have to consider that you will create the experience for the asset creators, like a converge both of them. Because by the end of the day, I assume they want to see something like this, right? Unified and some sort of UI, etc., etc. But behind the curtains here, we have two specs. We have interactivity and audio graph, right? And it's kind of mental process that we need to start to think how we can probably start to express this thingy, converging interactivity and audio graph. And that's pretty much it. Again, that's work in progress. Well, we have something working on top of this. And we see, again, we kind of cover all the use cases. But if you think about this, actually what we do, we expose game engine, yes, kind of quality thingy, just based on the specs. It's not runtime. We never kind of enforced to use any runtime implementation. But think about this holistically. Actually, yeah, it's APIs. And it's a sort of the runtime control over this. So in one package, you can deliver and make sure you will get the applicable experience by default. So that's pretty much it. So I passing over back to Patrick and ready for answer questions.
Alexey and Dwight, look, awesome presentation. Thank you once again for coming. And Alexey, thanks for showing that connection there on the audio side. I think that's an interesting approach. So want to hand it over for questions. We have about 20 minutes for the official meeting and then any water cooler that could follow. So questions. Thomas has his hand up.
Yeah, I have a question for Dwight. Since I don't see Felix from the Needle team tonight, I wonder if a very simple thing that is possible with the Apple approach, like a constantly changing billboard, always facing to the user. Would this be possible with the current behavior graph?
Yeah. So yes, not only is that possible, but much more complicated ones are possible as well. You're able to make a node graph that sets the value of any property of the scene equal to any other property that you can compute from other properties in the scene. So if you read the camera values, do some math, output new values, put those into the transform of the billboard, you can make the billboard always point at the user. But because you can do any math you want, you could also do more complicated things like not just billboard something to face towards a user, but you could billboard something to face towards another object that's moving around. You could have something constantly move around to avoid a user when a user gets close to it. There's lots of things that you could do. Basically, if it's something that you could compute the transform that you want from all of the other transforms in the scene, then you can do it.
So when I recall correctly, the camera position, the absolute position, was formerly a privacy concern, and that is now fully open.
A good point. I should say that you would be able to do that in any system that is allowed to give you the camera transform. There is a path to get the camera transform, and it is not guaranteed to be filled out depending on the privacy context that you're in. If you were to billboard just by saying this object should be billboarded, then in order to meet the privacy constraints, you would have to then be unable to read the transforms of any objects within the hierarchy of the thing that is billboarded. Otherwise, you could derive the camera location through various mathematical means, right? And so there has also been a question of whether we should have a separate extension for billboarding that is sort of privacy conscious. We don't have that yet, but yes, we currently have a more powerful but less but doesn't work when the camera transform needs to be hidden.
Thank you very much.
Leonard, I think your hand up next.
Yeah, so separately from work Dwight has been doing, there is a preliminary, let's say, concept proposal for billboards. And it is subject to the same camera restrictions because the camera information is obtained directly from the device, and the privacy filters and user approvals occur before the data is even available to anything at JavaScript level. So prior to any of the, whether it's an extension or something related to interactivity, which is also an extension, but whether it's a separate billboard extension or interactivity, just getting the data into JavaScript from no matter what part of JavaScript it is subject to the device privacy controls and user approvals of release of that.
Yeah, and I will just add to the previous comment on the privacy versus capability thing. I'm not sure that the other proposal, the trigger and action one, was actually successfully private either. I think it may be possible to set up combinations of billboarded objects and collision triggers that would allow you to measure the rotation that was applied to the billboarded object and therefore do the trigonometry. So I think at a not necessarily at a perfect level of precision, but at some level of precision, I think you could derive the camera angle from that one too.
But there isn't any way to. There isn't any way to send out those values. That's right. the main difference.
Yes, there's no network access in either of the systems. There's no network access. So yes, you can have calculated the camera position, but then what can you do with it? All you can do is, I don't know, change the color of a transform or change the color of a material, or change the transform of an object to be related to the camera data. It's the security we felt was the most important is on what can be sent out. And so a system that wants to give you full capability to billboard things may simply not provide any vendor extensions that would have given you any ability for data to come out of the system. Nick, go ahead.
Yeah, so my question is, I think it's pretty clear from what you just said, but I want to confirm. So you talked about taking two values, like two attributes, and computing another value and applying them to another attribute in order to cause something to change. I think in that case, what you're talking about is that the change is applied to the rendering of a thing, as opposed to modifying the scene graph per se. Is that correct?
The model that we're taking, you can't change anything about the structure of a scene graph. So you could never change things about like this node is parented to some other node now or something of that sort. You can set new transforms for objects, whether you want to consider that part of the rendering of it or whether you want to consider it part of the scene graph itself. It probably makes sense to consider it part of the rendering of it. If you set a transform and then you played an animation and the animation overwrote the transform, we would be seeing the animation and the other would go away. If after the animation completes, you then set a transform again, it would be now in a new location. But when you read the properties, you are reading the ones that we set. So if you wanted to find out where is this object now, you'll get the where is it now based on the last thing that was written to it.
I see. That seems to open some cans of worms. Like if I have a position and my script says that position is equal to position plus 1, I have a loop. And so you've got a resolution problem there.
Oh, yes. So this is not the same as a constraint. This is an action that you can apply. Either you apply it when you get a tap event, or you apply it when you get a tick event. But it's not like a constraint system where it is constantly being applied as anything changes. So if you do have a loop, it will simply mean that every frame it will move forward one.
Every frame it will move forward one. And so the related question that I had is concurrent. So if a whole bunch of things respond to the same thing at the same time, for example, one reads attribute, another one reads an attribute, and then they compute separate things. There could be an order dependence problem if they all resolve in the same tick into the graph, as opposed to resolving into a resolve target where everybody in the same tick would have a consistent source of truth.
Yes. I'm trying to remember exactly what our solution was on that. We do have that somewhere written in the spec, I believe, about how we are handling that. I recall at some point the discussion involved things like, do you always read the sort of snapshot of where everything was at the end of the last frame? Or can you read back other changes that have been already made this frame? But I don't recall if that was actually the solution we went with or if something slightly more complex was in the spec. But yes, this is a bit of an issue. We think we're doing it similarly to the way that Unity and Unreal and the others have usually done it. And yeah, it's often up to the content creator to create the content in a way that doesn't run into the most ambiguous cases.
My final comment is that if you have the ability to write back into the scene graph per se, if this was embedded in USD, that could have a consequence of forcing recomposition of the scene. So it might be a bottomless pit of complexity and expense if you can modify the scene graph on the fly.
Yeah, I wouldn't recommend.
Or even
yeah,
properties specifically, like if you have variants and things like that might be keyed off a value themselves.
Yeah, I would recommend treating this more similarly to how you query the value of something that is being animated. But you would need it to be a sort of another state system, right? Because it can be changed over time, and it does need to know where it was last changed to.
Mm-hmm. I assume that if I read the spec in detail, I'll probably find those answers.
Yes, I hope you do. And if you don't find the answers, then let us know where we can be more precise, and we'd be happy to update the spec.
Thank you.
Then Nick, before we go to Kev's question here, just from the USD perspective, coarse grain direction here, what do you think, right? If we took out a crystal ball of 1, 2, 3 years from now, do you like the direction that we're going here with glTF?
I do like that it's clearly spelled out what's supposed to go on, and I'm like poking away at things where there might be subject to interpretation that could result in two people making the same thing that behave completely differently because they read the spec differently. So I'm mostly on the lookout for things like that and complications like writing back to the scene graph causing, for example, a recurrent recomposition. So as long as there aren't these sorts of pitfalls, I think that this is my favorite variant of this concept to date. I'll put it that way, like from a personal rather than a official standpoint.
Cool.
Understood.
And from a
Sorry,
philosophical perspective, we've generally been taking the philosophy that as a content creator, there are some things that you just ought not do. And if you don't do those, we ought to be able to guarantee consistency. And if you do those things, we might not guarantee consistency, but please don't do those things. That's been our solution rather than saying there will always be perfect consistency on absolutely everything, because we felt like the burden on the implementers can become too high if we're trying to make everything work, even the things that we may strongly advise against doing. We do try to minimize the constraints of where you shouldn't do particular things, but that's been the philosophy so far. Ken, can you have your hand up?
Oh yeah, thanks for that. So got a few questions actually, but I'll just ask them one at a time, just let other people jump in. So the first one's around custom events. So I guess a lot of us are probably going to like reintroduce like keyboard and mouse movements and that sort of stuff. And I haven't had a deep look at this spec for a while, but I don't think I spotted them in there before. Will they ever be part of the core spec, or is there perhaps maybe some kind of extension for them? Or
yeah, so anyone can make their own vendor extensions. Anyone can, of course, propose new extensions to be added for ratification to Kronos. And anyone can make custom events. So there's sort of 3 ways to move things forward on that. New extensions can define new events. They can define new nodes. They can define new properties that can be manipulated. My understanding is that the one major interaction event that we are providing either in the base spec or in an extension that comes right after it is the tap type of event. I think we're calling it select because in VR that seems to be the term that's preferred, but it basically is the user specifying an intent to cause this object to do something. And whether they do that by a mouse, whether they do that by a finger, whether they do it by a VR controller, we're trying to cover that case. Beyond that, we do expect that future extensions may cover other things. Within the VR case, there may be all sorts of additional information people may want from their controllers. That could be a potential future extension. Within a desktop, there may be totally different things. That could, again, also be a future extension. And then particular environments, like if you were making a metaverse thing where you were loading in multiple different interactive objects, then you might simply specify, hey, here are all the custom events that I'm creating from a custom event perspective, or here's my vendor extension for additional things for when you know you're interacting within my particular environment.
thanks. So that is actually the use case I've been thinking of, more the kind of metaverse game engine type thing. And just it's probably worth out. So in the OpenUSD games group, we've kind of been looking a bit at level of details like LODs recently. So one of the challenges came up that was about addressability. So I've been trying to match the spec to OpenUSD, and the easiest way is obviously just to replace it with a kind of path and a OpenUSD like SDF path. That's a string and it kind of plugs in. But I suppose just to mention one of the challenges that is if you change to a different object because you want to switch LODs, then that path may not be valid. So it's not really a question, but I guess it was more kind of just flagging something that's come up in that kind of environment.
Yeah,
there are definitely ways around it, but there's not a definitive way around it just yet. But
yeah, in general, we've assumed that your interactivity has to go with a particular scene graph, and that scene graph has to be relatively immutable. And so if you were bringing in an object that had multiple LODs, and those different LODs were more than just different textures and different vertices, vertex counts, but rather was a different was an entirely different structure, fewer nodes or more nodes or whatever else, right? Then it may make the most sense to reauthor your interactivity separately for each different level of detail. Not only because that way it references the versions that you have there, but also because potentially if your lower level detail version of a character had fewer bones than the full version of the character, your interactivity might need to be a different set of interactivity graphs because it needs to deal with the simplified bone or the simplified skeleton, I mean.
Yeah, makes sense. Thanks. Just one other quick question for now is so I've been working on an implementation of it, and I used the old Behave Graph library. I think it was Ben Houston who made it, and it was interesting to see that there was a link to a new tool there. Is one based off the other? Are they, or is it a completely new implementation? The link you shared today.
I don't recall whether the new one that I shared today started from Behave Graph. I think it may have, but this is the one that's been kept up to date with every change that we've been making in the meetings. I believe, I'm not entirely sure, but I believe that Behave Graph stopped updating at some point and is not up to speed with the latest spec changes.
Great, thanks. Look forward to checking that out.
Yeah, or maybe it has been updated. If so, it may be that this thing uses Behave Graph under the hood, but it would be good to check that. This is the one that I'm sure he shows up, the author of this shows up in our meetings every week, and he's always telling us how close he is to the latest changes that we made from the previous week. So we know this one's maintained.
Thanks.
Cool. Okay, so we're kind of wrapping up the main part of the meeting, but of course can roll into water cooler. So still time for additional discussion.
I had a question for Alexey, which is, do the KHR audio nodes correspond one-to-one with nodes in the web audio specification? Or is this a new
No, it's a new one
for an audio graph?
Yeah, it's actually that's the link. Let me try to open this. No, it's more about the spatial audio. So that's a bunch of spatial oriented stuff, but I assume that might be some intersection, especially about the processing nodes.
Yeah, like I saw things like oscillators, which of course
yeah. Those processing nodes can be similar. Actually, that's a good question. Probably I should like double check if we can be at least closer. But everything that related to the actual sources and emitters, etc. So that I think specific for the spatial audio.
Yeah, cool. Well, on behalf of people who use web audio, it sure would be nice if the nodes that are common share a definition, especially since,
Yeah, I'll do this. Thanks.
Thank you.
Nick, on that topic, when we had the preliminary discussions on how this should be done, we kept referring to the web audio spec and design. So it's possible.
Yeah, clearly they share a heritage. But I think I just want to suggest it would serve the community if they're explicitly known to be compatible so that people aren't on the hook to write translators to figure out how does this parameter map onto this other parameter with the same name? Are they really the same? Just saying that they are the same would be super helpful.
Yeah. That's yes, thanks. That's amazing input. Yes, I will make sure we align on this.
And I have another meeting that I need to run to, but maybe I can take one more question if that's a question for me, Samset. Greg, I guess.
Yeah, hi guys. Great stuff. I'm trying the DCC React app right now, and I'm just wondering if you have any example behave graphs and world JSON I could try in there. Especially, I'm looking for uh, full extensive examples of the JSON. And I'm particularly interested in the audio part of it as well. And
Okay.
also, final question, just what kind of external packages are available for running this in, interpreting this in Unity or something like that?
Yeah, good question. So first, there are, I think, some examples somewhere in that repo, but they are not extensive. They are relatively small. There is a plan to get some more in there soon, but they're not there yet. We didn't want to create large numbers of really complicated ones while the spec was still changing. The spec is no longer still changing, but that's pretty recent. So that's why you're not seeing bigger, more extensive examples there. As far as being able to run these in Unity, we do have one person who comes to the meeting relatively frequently who seems to express an interest in making the importers and exporters between this and Unity. He has not given me any dates to give on when he would deliver things or promises to give, so I probably can't speak on his behalf, but I do feel like there are people at that meeting who are hoping to make that happen. So that would be a future thing. And then lastly, audio, also a future thing. I don't believe that particular version has the audio support yet. That one's still in progress.
Great, thank you. Appreciate it.
Cool, thank you.
So Dwight, given that you have to roll, maybe we'll end the official meeting, but then folks can still hang on for more water cooler. So just to wrap up, let's do a round of applause here for Alexey and Dwight.
Thanks.
Thanks for joining us, Dwight. I'll just stop the recording, but let's keep hanging out for folks who have time.